Good evening everybody. Today we are going to speak about collision theory. The rate of the reaction depends upon the collision frequency and the effective collisions according to the collision theory. The atoms or molecules considered as hard spheres which undergo the collision in order to form a product. A plus B gives the product. K is equal to, that is K is denoted as the rate of the reaction is equal to ZAB e power minus EA by RT, where ZAB is the collision frequency, the number of collisions per second per unit volume of the reaction mixture is called collision frequency. Not all collisions lead to the formation of products. Only the effective collisions can lead to the lead to formation of a product. The effective collision can be done when the hard spheres have proper orientation and correct kinetic energy. So that is called effective collision. Now equation 1 becomes K is equal to P ZAB e power minus EA by RT, where P is equal to the probability or the steric factor. It is nothing but it is a factor which accounts for the proper orientation of the reactant mixture. Now we will see an example for this. We will take CH3Br plus OH minus. C contains a positive charge and Br contains a partial negative charge. We will see about improper orientation. When CH3Br is hit from this side, we will see partial negative charge and a minus charge. It doesn't form any product. It cannot combine. So it doesn't form any product. Whereas in proper orientation, it forms an intermediate. It attacks from this side. So it forms an intermediate like this, CH3OH plus OHBr, and gives out a product CH3OH plus Br minus. This is what effective collision is all about. It needs proper orientation and a proper kinetic energy. We are going to see about comparison of physisorption and chemisorption. Before going into this, we will see about adsorption. Adsorption is nothing but the phenomenon of accumulation of higher concentration particles at the surface of the bulk or a solid is known as adsorption. Now, we have types of adsorptions, that is physisorption and chemisorption. Physisorption is formed due to the van der Waals force, and chemisorption is formed due to the chemical bondings between the particles. In physisorption is not specific in nature, while chemisorption is specific in nature. Physisorption is reversible in nature. That is, when we use a duster to dust the particles off, it gets absorbed in the duster. So when we dust it off from the duster, it is reversible. It goes off. So that is reversible in nature, while it is not possible in chemisorption. It is irreversible. It forms a chemical bonding. It becomes difficult to break easily. So here in physisorption, the enthalpy of adsorption is low. That is vaguely up to 20 to 40 kilojoule per mole, where the enthalpy of adsorption for chemisorption is very high. We can see here that is 80 to 240 kilojoule per mole. Physisorption favors low temperature. Physisorption decreases with increasing temperature, while chemisorption increases with increasing temperature. Physisorption can form multimolecular layer, whereas in chemical absorption we can form unimolecular layer because it can accumulate more and more layers where it can't accumulate because it forms a chemical bonding. Here we need less activation energy, EA, and we in chemical absorption we need high activation energy. Now we are going to see about mechanism of micelle formation. Soap is a sodium or potassium salt of higher fatty acids which have RCOO minus Na plus. For example, we will see sodium stearate, which is the most common and a major component of our bar soaps in which we use in our daily life. Its molecular formula is CH3 CH216 COO minus Na plus. For example, we can take about Rin soap which we use to wash our clothes. When the soaps are dissolved in water, it dissociates and form RCOO minus ions and Na plus ions. When we see about RCOO minus ions, we can divide it into two. R, the longest carbon chain, alkyl group. It is also known as non-polar tail. And hydrophobic. Hydrophobic means it hates water. It tends to escape from the water surface. Where on the other hand, COO minus is polar group. It is polar and it is known as polar ionic head. And hydrophilic. It is hydrophilic. Hydrophilic means it loves water. It attract to water. We can see a missile. It is like this. Hydrophobic tail and hydrophilic head. It contains COO minus ions. It has the R. So here is a diagram which represents micelle formation. RCOO minus present on the surface. It is always present on the surface. Where COO minus ions in water and hydrophobic tail in surface. Ions are pulled into the bulk of the solution and it gets aggregate and it forms a micelle. Form a spherical ball with micelle. It contains hundreds and thousands of micelle in it. It takes all the dirt in the cloth or whatever we wash. R, it points towards the center, and COO, it is outward from the center.